Essay on the Theory of the Earth, published in 1813, by Baron Georges Cuvier, Perpetual Secretary of the French Institute, Professor and Administrator of the Museum of Natural History. Preliminary observations. In my work on fossil bones, the object which I proposed was to discover to what animals the osseous remains, with which the superficial strata of the globe are filled, may have belonged. In pursuing this object, I had to follow a path in which but little progress had hitherto been made. As an antiquary of a new order, I was obliged at once to learn the art of restoring these monuments of past revolutions to their original forms, and to discover their nature and relations. I had to collect and bring together in their original order the fragments of which they consisted, to reconstruct, as it were, the ancient beings to which these fragments belonged, to reproduce them with all their proportions and characters, and, lastly, to compare them with those which now live at the surface of the globe, an art almost unknown, and which presupposed a science whose first developments had scarcely yet been traced, that of the laws which regulate the coexistence of the forms of the different parts in organized beings. I had therefore to prepare myself for these inquiries, by others of a far more extensive kind, respecting the animals which still exist. Nothing, except an almost complete review of creation in its present state, could give a character of demonstration to the results of my investigation into its ancient state, but from this review, I had at the same time to expect a great body of rules and affinities not less satisfactorily demonstrated, and it became obvious that, in consequence of this essay upon a small portion of the theory of the earth, the whole animal kingdom would necessarily be in some measure subjected to new laws. Thus I was encouraged in this twofold investigation by the equal interest which it promised to possess, both with regard to the general science of anatomy, the essential basis of all those which treat of organized bodies, and with regard to the physical history of the globe, the foundation of mineralogy, geography, and even, it may be said, of the history of man, and of all that it most concerns him to know with regard to himself. If it be so interesting to us to follow, in the infancy of our species, the almost obliterated traces of extinct nations, why should it not also be so, to search, amid the darkness of the infancy of the earth, for the traces of revolutions which have taken place anterior to the existence of all nations? We admire the power by which the human mind has measured the motions of the celestial bodies, which nature seemed to have concealed forever from our view. Genius and science have burst the limits of space, and observations, explained by just reasoning, have unveiled the mechanism of the universe. Would it not also be glorious for man to burst the limits of time, and, by means of observations, to ascertain the history of this world, and the succession of events which preceded the birth of the human race? Astronomers have undoubtedly advanced more rapidly than naturalists, and the present period, with respect to the theory of the earth, bears some resemblance to that in which some philosophers fancied that the heavens were formed of polished stones, and that the moon was of the size of the Peloponnesus. But after Anaxagoras, came Copernicus and Kepler, who pointed the way to Newton. And why should not natural history also one day have its Newton? 1. Plan of this essay. What I especially propose to present in this discourse is the plan and the result of my labors regarding fossil bones. I shall also attempt to trace a rapid sketch of the efforts that have been made up to the present day to restore the history of the revolutions of the globe. The facts which I have been enabled to discover form, without doubt, only a small portion of those which would be necessary to complete this ancient history, but several of them lead to decisive consequences, and the rigorous manner in which I have proceeded in their determination affords me reason to think that they will be regarded as points definitively fixed, and which in their aggregate will form an epoch in science. Lastly, I trust their novelty will be a sufficient excuse for me, if I claim for them the earnest attention of my readers. My object will first be to show by what relations the history of the fossil bones of terrestrial animals connects itself with the theory of the Earth, and for what reasons a peculiar importance is to be attributed to it, with reference to this subject. I shall then unfold the principles upon which is founded the art of determining these bones, or, in other words, of recognizing a genus, and of distinguishing a species by a single fragment of bone, an art, on the certainty of which depends that of my whole work. I shall give a rapid account of the new species, and of genera previously unknown, which the application of these principles has led me to discover, as well as the different kinds of deposits in which they are contained. And as the difference between these species and those which exist at the present day is bounded by certain limits, I shall show that these limits much exceed those which now distinguish the varieties of the same species. I shall therefore make known to what extent these varieties may go, whether from the influence of time, or from that of climate, or, lastly, from that of domestication. In this way I shall be enabled to conclude, and to induce my readers to conclude with me, that great events were necessary to produce the more considerable differences which I have discovered. I shall next mention the particular modifications which my researches must necessarily introduce into the hitherto received opinions regarding the revolutions of the globe, and, lastly, I shall inquire how far the civil and religious history of different nations corresponds with the results of observation with regard to the physical history of the earth, and with the probabilities which these observations afford concerning the period at which societies of men may have found fixed places of abode, and fields susceptible of cultivation, and at which, therefore, they may have assumed a durable form. 2. First appearance of the earth. When the traveller passes over those fertile plains where gently flowing streams nourish in their course an abundant vegetation, and where the soil, inhabited by a numerous population, adorned with flourishing villages, opulent cities, and superb monuments, is never disturbed, except by the ravages of war, or by the oppression of the powerful, he is not led to suspect that nature also has had her intestine wars, and that the surface of the globe has been broken up by revolutions and catastrophes. But his ideas change as soon as he digs into that soil which now presents so peaceful an aspect, or ascends to the hills which border the plain. His ideas are expanded, if I may use the expression, in proportion to the expansion of the view, and begin to embrace the full extent and grandeur of those ancient events, when he climbs the more elevated chains, whose base is skirted by these hills, or when, by following the beds of the torrents which descend from those chains, he penetrates, as it were, into their interior. 3. First proofs of revolutions on the surface of the globe. The lowest and most level parts of the earth exhibit nothing, even when penetrated to a very great depth, but horizontal strata composed of substances more or less varied, and containing almost all of them innumerable marine productions. Similar strata, with the same kind of productions, compose the lesser hills to a considerable height. Sometimes the shelves are so numerous as to constitute of themselves the entire mass of the rock. They rise to elevations superior to the level of every part of the ocean, and are found in places where no sea could have carried them at the present day, under any circumstances. They are not only enveloped in loose sand, but are often enclosed in the hardest rocks. Every part of the earth, every hemisphere, every continent, every island of any extent, exhibits the same phenomenon. The times are past when ignorance could maintain, that these remains of organized bodies are mere sportings of nature, productions generated in the womb of the earth, by its own creative powers, and the efforts made by some metaphysicians of the present day will not probably succeed in bringing these exploded opinions again into repute. A scrupulous comparison of the forms of these remains, of their texture, and often even of their chemical composition, does not disclose the slightest difference between the fossil shells and those which still inhabit the sea. The preservation of the former is not less perfect than that of the latter. Most commonly we neither observe detrition nor fracture in them, nothing, in short, that announces a violent removal from their original places. The smallest of them retain their sharpest ridges, and their most delicate spines. They have, therefore, not only lived in the sea, but they have also been deposited by it. It is the sea which has left them in the places where they are now found. But this sea has remained for a certain period in those places. It has covered them long enough, and with sufficient tranquility to form those deposits, so regular, so thick, so extensive, and partly also so solid, which contain those remains of aquatic animals. The basin of the sea has therefore undergone one change at least, either in extent or in situation. Such is the result of the very first search, and of the most superficial examination. The traces of revolutions become still more apparent and decisive when we ascend a little higher and approach nearer to the foot of the great chains. There are still found many beds of shells. Some of these are even thicker and more solid. The shells are quite as numerous and as well preserved, but they are no longer of the same species. The strata which contain them are not so generally horizontal. They assume an oblique position, and are sometimes almost vertical. While in the plains and low hills it was necessary to dig deep, in order to discover the succession of the beds, we here discover it at once by their exposed edges, as we follow the valleys that have been produced by their disjunction. Great masses of debris form at the foot of the cliffs, rounded hills, the height of which is augmented by every thaw and tempest. These inclined strata, which form the ridges of the secondary mountains, do not rest upon the horizontal strata of the hills which are situate at their base, and which form the first steps in approaching them, but, on the contrary, dip under them, while the hills in question rest upon their declivities. When we dig through the horizontal strata in the vicinity of mountains whose strata are inclined, we find these inclined strata reappearing below, and even sometimes, when the inclined strata are not too elevated, their summit is crowned by horizontal ones. The inclined strata are therefore older than the horizontal strata, and as they must necessarily, at least the greater number of them, have been formed in a horizontal position, it is evident that they have been raised, and that this change in their direction has been effected before the others were superimposed upon them. Thus the sea, previous to the deposition of the horizontal strata, had formed others, which, by the operation of problematical causes, were broken, raised, and overturned in 1,000 ways, and, as several of those inclined strata which it had formed at more remote periods, rise higher than the horizontal strata which have succeeded them, and which surround them, the causes by which the inclination of these beds was effected, had also made them project above the level of the sea, and formed islands of them, or at least shoals and inequalities, and this must have happened, whether they had been raised by one extremity, or whether the depression of the opposite extremity had made the waters subside. This is the second result, not less clear, nor less satisfactorily demonstrated, than the first, to everyone who will take the trouble of examining the monuments on which it is established. 4. Proofs that such revolutions have been numerous. but it is not to this subversion of the ancient strata, nor to this retreat of the sea after the formation of the new strata, that the revolutions and changes which have given rise to the present state of the earth are limited. When we institute a more detailed comparison between the various strata and those remains of animals which they contain, we presently perceive that this ancient sea has not always deposited mineral substances of the same kind, nor remains of animals of the same species, and that each of its deposits has not extended over the whole surface which it covered. There has existed a succession of variations, the former of which alone have been more or less general, while the others appear to have been much less so. The older the strata are, the more uniform is each of them over a great extent. The newer they are, the more limited are they, and the more subject to vary at small distances. Thus the displacements of the strata were accompanied and followed by changes in the nature of the fluid, and of the matters which it held in solution, and when certain strata, by making their appearance above the waters, had divided the surface of the seas by islands and projecting ridges, different changes might take place in particular basins. Amidst these variations in the nature of the general fluid, it is evident that the animals which lived in it could not remain the same. Their species, and even their genera, changed with the strata, and, although the same species occasionally recurred at small distances, it may be announced as a general truth that the shells of the ancient strata have forms peculiar to themselves, that they gradually disappear, so as no longer to be seen at all in the recent strata, and still less in the presently existing ocean, in which their corresponding species are never discovered, and where several, even of their genera, do not occur, that, on the contrary, the shells of the recent strata are similar, in respect to their genera, to those which exist in our seas, and that, in the latest and least consolidated of these strata, and in certain recent and limited deposits, there are some species which the most experienced eye could not distinguish from those which are found in the neighboring seas. There has, therefore, been a succession of variations in the economy of organic nature, which has been occasioned by those of the fluid in which the animals lived, or which has at least corresponded with them. And these variations have gradually conducted the classes of aquatic animals to their present state, till, at length, at the time when the sea retired from our continents for the last time, its inhabitants did not differ much from those which are found in it at the present day. We say for the last time, because, if we examine with still greater care those remains of organized bodies, we discover, in the midst of even the oldest strata of marine formation, other strata replete with animal or vegetable remains of terrestrial or freshwater productions, and, amongst the more recent strata, or, in other words, those that are nearest the surface, there are some in which land animals are buried under heaps of marine productions. Thus, the various catastrophes which have disturbed the strata have not only caused the different parts of our continents to rise by degrees from the bosom of the waves and diminished the extent of the basin of the ocean, but have also given rise to numerous shiftings of this basin. It has frequently happened that lands which have been laid dry have been again covered by the waters, in consequence either of their being engulfed in the abyss, or of the sea having merely risen over them. The particular portions also of the earth, which the sea abandoned in its last retreat, those which are now inhabited by man and terrestrial animals, had already been once laid dry, and had then afforded subsistence to quadrupeds, birds, plants, and land productions of all kinds. The sea which left it had, therefore, covered it at a previous period. The changes in the level of the waters have not, therefore, consisted solely in a more or less gradual, or more or less general retreat. There have been various successive eruptions and retreats, the final result of which, however, has been a universal depression of the level of the sea. 5. proofs that these revolutions have been sudden. It is of much importance to remark that these repeated eruptions and retreats of the sea have neither all been slow nor gradual. On the contrary, most of the catastrophes which have occasioned them have been sudden, and this is especially easy to be proved with regard to the last of these catastrophes, that which, by a twofold motion, has inundated, and afterwards laid dry, our present continents, or at least a part of the land which forms them at the present day. In the northern regions, it has left the carcasses of large quadrupeds which became enveloped in the ice, and have thus been preserved even to our own times, with their skin, their hair, and their flesh. If they had not been frozen as soon as killed, they would have been decomposed by putrefaction. And, on the other hand, this eternal frost could not previously have occupied the places in which they have been seized by it, for they could not have lived in such a temperature. It was, therefore, at one and the same moment that these animals were destroyed, and the country which they inhabited became covered with ice. This event has been sudden, instantaneous, without any gradation, and what is so clearly demonstrated with respect to this last catastrophe is not less so with reference to those which have preceded it. The breaking to pieces, the raising up and overturning of the older strata, leave no doubt upon the mind that they have been reduced to the state in which we now see by the action of sudden and violent causes, and even the force of the motions excited in the mass of waters is still attested by the heaps of debris and rounded pebbles which are in many places interposed between the solid strata. Life, therefore, has often been disturbed on this earth by terrible events. Numberless living beings have been the victims of these catastrophes. Some, which inhabited the dry land, have been swallowed up by inundations. Others, which peopled the waters, have been laid dry, from the bottom of the sea having been suddenly raised. Their very races have been extinguished forever, and have left no other memorial of their existence than some fragments, which the naturalist can scarcely recognize. Such are the conclusions to which we are necessarily led by the objects that we meet with at every step, and which we can always verify by examples drawn from almost every country. These great and terrible events are everywhere distinctly recorded, so as to be always legible by the eye skilled to decipher the history and the monuments which they have left behind. But what is still more astonishing and not less certain, life has not always existed upon the globe, and it is easy for the observer to distinguish the point at which it has begun to deposit its productions. 6. Proofs that there have been revolutions anterior to the existence of living beings. If we are sent to higher points of elevation, and advance towards the great ridges, the craggy summits of the mountain chains, we shall presently find those remains of marine animals, those innumerable shells, of which we have spoken, becoming more rare, and at length disappearing altogether. We arrive at strata of a different nature, which contain no vestiges of living beings. Nevertheless, their crystallization, and even their stratification, show that they have been also in a liquid state at their formation. Their inclined position, and the cliffs into which they are broken, show that they also have been forcibly moved from their original places. The oblique manner in which they dip under the shelly strata, that they have been formed previously to these latter, and lastly, the height to which their rugged and bare peaks rise above all these shelly strata, that their summits had already emerged from the waters, when the shelly strata were forming. Such are those celebrated primitive mountains which traverse our continents in different directions, raising themselves above the clouds, separating the basins of rivers from one another, affording, in their perennial snows, reservoirs which feed the springs, and forming, in some measure, the skeleton, and as it were the rough framework, of the earth. the eye perceives from afar, in the indentations with which their ridge has been marked, and in the sharp peaks with which it is bristled, indications of the violent manner in which they have been elevated. Their appearance, in this respect, is very different from that of those rounded mountains and hills with long flat surfaces, whose less ancient masses have always remained in the situation in which they were quietly deposited by the waters of more recent seas. These indications become more obvious as we approach. The valleys have no longer those gently sloping sides, those salient and re-entering angles corresponding on either side to each other, which seem to denote the beds of ancient streams. They widen and they contract without any general rule. Their waters, at one time, expand into lakes, at another, fall in torrents, and sometimes their rocks, suddenly approaching from each side, form transverse dikes, over which the waters tumble in cataracts. The dissevered strata, while they show on one side their edges perpendicularly raised, on the other present large portions of their surface lying obliquely. They do not correspond in height, but those which, on one side, form the summit of the cliff, often dip underneath on the other, and are no longer visible. Yet, amidst all this confusion, distinguished naturalists have been able to demonstrate that there still reigns a certain order, and that those immense deposits, broken and overturned though they be, observe a regular succession with regard to each other, which is nearly the same in all the great mountain chains. According to them, granite, of which the central ridges of the greater number of these chains consist, and which thus surmounts every other rock, is also the rock which is found deepest in the solid crust of the globe. It is the most ancient of those which we have found means of examining in the place assigned them by nature, and we inquire not at present whether it owes its origin to a general fluid, which formerly held everything in solution, or may have been the first consolidated by the cooling of a great mass in fusion, or even in a state of vapor. Foliated rocks rest upon its sides, and form the lateral ridges of these great chains. Schists, porphyries, sandstones, and talcose rocks intermingle with their strata. Lastly, granular marbles and other limestones destitute of shells, resting upon the schists, form the outer ridges, the lower steps as it were, the counterfeits of these chains, and are the last formations by which this unknown fluid, this sea without inhabitants, would seem to have prepared materials for the mollusca and zoophytes, which were presently to deposit upon these foundations vast heaps of their shells and corals. We even find the first productions of these mollusca and zoophytes appearing in small numbers, and scattered at greater or less distances, in the last strata of these primitive formations, or in that portion of the crust of the globe to which geologists have given the name of transition rocks. Here and there we meet with beds containing shells, interposed between certain granites of later formation than the others, between schists of various kinds, and between some newer beds of granular marbles. Life, which was in the end to obtain entire possession of the globe, seems, in these primordial times, to have struggled with the inert nature which formerly predominated, and it was not until a considerable time after that it obtained the ascendancy over it, and acquired for itself the exclusive right of continuing and elevating the solid envelope of the earth. Hence, it is impossible to deny that the masses which now constitute our highest mountains have been originally in a liquid state, and that they have for a long time been covered by waters in which no living beings existed. Thus, it has not been only since the appearance of life that changes have been operated in the nature of the matters which have been deposited, for the masses formed previous to that event have varied, as well as those which have been formed since. they have also experienced violent changes in their position, and that part of these changes must have taken place at the period when these masses existed by themselves, and were not covered over by the shelly masses. The proof of this lies in the overturnings, the disruptions, and the fissures, which are observable in their strata, as well as in those of more recent formations, and which are in the ancient strata even in greater number and better defined. But these primitive masses have also undergone other revolutions since the formation of the secondary strata, and have, perhaps, given rise to, or at least have partaken of, some of those changes which these strata themselves have experienced. There are actually considerable portions of the primitive formations uncovered, although placed in lower situations than many of the secondary formations, and we cannot conceive how it should have so happened unless the primitive strata in those places had forced themselves into view after the secondary strata had been formed. In certain countries, we find numerous large blocks of primitive substances scattered over the surface of secondary formations, and separated by deep valleys, or even by arms of the sea, from the peaks or ridges from which they must have been derived. We must necessarily conclude, therefore, either that these blocks have been ejected by eruptions, or that the valleys, which must have stopped their course, did not exist at the time of their being transported, or, lastly, that the motions of the waters by which they were transported exceeded in violence anything that we can imagine at the present day. Here, therefore, we have a collection of facts, a series of epochs, anterior to the present time, of which the successive steps may be perfectly ascertained, although the duration of their intervals cannot be defined with precision. They are so many fixed points, which serve to regulate and direct our inquiries respecting this ancient chronology. 7. Examination of the causes which act at present on the surface of the globe. Let us now examine those changes which are taking place at the present day upon the globe, investigating the causes which still act in its surface, but endeavoring to determine the possible extent of their effects. This portion of the history of the earth is so much the more important, that it has long been considered possible to explain the more ancient revolutions on its surface by means of these still existing causes, in the same manner as it is found easy to explain past events in political history by an acquaintance with the passions and intrigues of the present day. But we shall presently see that unfortunately the case is different in physical history. The thread of operations is here broken. The march of nature is changed, and none of the agents which she now employs would have been sufficient for the production of her ancient works. There still exist, however, 4 causes in full activity, which contribute to alter the surface of our continents. These are rains and thaws, which waste down the steep mountains, and precipitate the fragments to their bottoms, running waters, which carry off these fragments, and deposit them in places where the current is abated, the sea, which undermines the foundations of elevated coasts, forming steep cliffs, and which throws up great banks of sand upon the low coasts, and, lastly, volcanoes, which pierce through the solid strata from below, elevate these strata, or spread over the surface vast quantities of ejected matter. The Theory of the Earth, Georges Cuvier. College Museum, Edinburgh, the 25th of November 1826.